Okay, ready and okay. Go ahead and explain it, or should I start with asking you questions, Patrick?
Start by asking me questions.
Okay, so let's see. I've been feeling a little bit behind the times because I see that most of my programs use for loops or while loops or something to to work with to do things over and over again. And I have seen that many programmers have moved on to what appears to me to be a replacement for it, which is, for example, functions like map, map, reduce, zip, fold, and I can see that sometimes reverse is brought in there too. So my question is how can I, for example, in what way could I use such functions to replace let's say a regular for loop? Let's say, for example, first I want to loop from the number 2 to the number 7. I would do that with a regular for loop. How would I replace that using these other functions, Patrick?
Well, I think the trick is to just kind of, this is a little bit abstract, but the idea is to you really have to think of lists as sort of objects in their own right. It's not just a collection of objects, but it's its own thing.
Okay.
So, for example, if you wanted to, looping from 1 to 7 is easy. You just say range 1 to 7.
Okay.
You could imagine a function which, takes two numbers and returns the list of all the numbers between them.
Yes, and I'm familiar that the Python for loop uses range instead of...
Yeah.
By the way, these functions like map are called higher order functions, right?
Yeah.
Yeah. So, can I use map instead of using for to do something from, let's say I want to display, what would be good? Let's say, let's say I have a for loop that loops from the number 2 to the number 7. And then I want to display the, let's say the square of each one of those numbers.
If you wanted to display, then map wouldn't be a good idea. Well, it might be a good idea. You just say map, map function x, print x times x.
Okay.
I don't know if that's valid JavaScript or not, but that's the idea.
By function x, you're talking about a... Oh, okay. X times x. Function x. Okay. I'm not really... Function x, you're talking about a first-class function. No, a first-class variable. Yeah?
Yeah, an anonymous function.
A lambda.
Yeah.
Okay. Why is it anonymous when you're calling it an x?
No, I'm calling it function. I'm not giving it a name. X is the variable.
Oh, okay. So, can you type that out on Skype? Because I can't really picture it really. Okay. Print x times x, okay. And then we would send to map an array which contains 2 to 7, right?
Yeah.
Okay. Now, is there a function called range which generates that array?
Yes, I think so. I mean, if you don't have one, it's
easy to make.
It's easy to make, yeah.
Okay. So, okay. So then, okay, so map would be what I want to do for a regular for loop that would loop around all the through a range from 2 to 7.
Yeah.
Okay. So map would be the right function for that.
Yeah.
Now I can imagine that if I wanted to loop from 7 to 2, I would use reverse, right?
Yeah. The reverse range.
Uh-huh. And then, and then let's see. So what about, what's zip?
What's zip? Zip is... Zip is something which... Zip takes 2 lists.
2 lists.
And returns a list containing pairs whose first element is taken from the first list and whose second element is taken from the second list.
Okay, so basically, let's say, so it can be used for something like if I have like, I don't know, a list of names and a list of last names and I want to like make a list of names and last names.
Yeah.
Okay. And, let's see. Okay, so I think I understand what zip is. And, finally, what is reduce?
What is reduce? Reduce is tricky.
Okay.
Like, reduce is for like aggregating all the values in our list into one.
I don't know what the word aggregating means.
Combine.
Okay.
So you have to specify the function that's used to combine.
Okay.
For example, reduce plus would get the sum of all the elements of the list.
Can you type it out on Skype, Patrick? Because I'm not good at imagining it.
I know the syntax, but let's say reduce function.
Reduce function x, y. Turn x plus y. 1, 2, 3, 4, 5, 6. Okay, so you're saying it like, you're saying that it adds up all the elements in the list.
Yeah.
But why is it x plus y? I don't understand that.
What else would it be?
Okay.
Oh right. Why does it only take 2 arguments?
What is y anyway?
Y is just...
If I was, let me, before you answer, if I was going to implement this in a for loop, Patrick.
Yeah.
I'd loop throughout the length of the list.
Yeah.
Then I would like have a sum, variable.
Yeah.
That would, yeah.
Alright, so let's just, give me a sec. Let's call our function, let's say we have a function called add. So this would be the old JavaScript way to do reduce. For I equals 1, sorry, I equals 0, I less than.
And to our listeners, I'll say that that they should take a look at what's at the written material that will be accompanying the podcast.
And then we have, hang on, sorry. I have to do this again.
Okay.
So we say x equals 1, 2, 3, 1, 0. Then we say for I equals 1, I less than length, length 1, 2, 3, I plus plus, x equals add x, 1, 2, 3, I. And what that does is, so that adds up all the elements of the list.
Okay, let me take a look. Okay. I'm a bit confused at the line that says x equals 1, the list, and then is that element 0 of the list?
Yeah, element 0 of the list, yeah.
Okay. So then the x inside the for loop is a different x?
No, it's the same x.
It's the same x, okay.
Yeah.
X equals add. Let me go back to seeing what add does. And x is the first element, then the second parameter you add is the list itself, and the third, no. It's the list and at the index of that we're currently looping around. Okay. Okay. I think I get it. Yeah. I may need a little more time to digest this, Patrick. But, so basically why is,
X is,
why do we need to even pass in y?
Oh, well, y is just the second argument.
Okay.
Think of like x as the running total, and y is the latest thing that we have to add to the total.
Okay, so instead of saying x comma y, which sounds pretty cryptic,
yeah,
I'd rather say like total comma counter, something like that.
Yeah, that's fine.
Okay.
And the point with reduce is that we don't have to limit ourselves to adding. We can, we can take products or do whatever we like. If we have any way of combining two things.
Okay.
If we can combine two things, then we can combine all the elements in the list.
Okay. So if instead of add we said like subtract, it would like give us the total negative. Okay, and multiply. If we made a function called multiply, it would multiply all the elements of the.
Yeah.
Okay, so it would seem to me, Patrick, a little bit. I don't really understand why we need to pass in the y. Wouldn't it be better if there were a reduce function that was more, it would seem more intuitive to me if you just had a reduce function where you pass in the name of the first class function.
Mm.
I mean, yeah. I mean the variable of the first class function.
That's what we're doing.
And the list itself. I don't see why we have to pass in y.
Oh no, we don't have to pass in y.
We don't?
The point is that the first class function takes 2 arguments.
Oh, okay.
Yeah. So yeah, this is perfectly valid. I'm not sure this is a good podcast.
Not sure this is a good podcast?
Yeah. Too much typing.
Okay. Patrick, going back to where I saw that you're typing the add equals function x comma y, return x y.
Yeah.
What is return x comma y there?
Return x comma y?
I thought you may have meant return x plus y.
Yeah, I meant return x plus y.
Okay. Okay. Now I understand why you need the y.
Yeah. Cool.
Okay. I think I now understand it totally, Patrick. Okay. So it's the x and the y are the arguments to the first class function itself.
Mm-hmm.
So they're not required arguments for reduce.
No.
Okay. And okay, so moving on, can we move on? What does fold do?
Fold's the same thing as reverse.
As reverse?
Sorry, not reverse, reduce.
As reduce? Yeah. Okay. Now, is there any other function similar to these higher class functions we've been talking about that I haven't mentioned? Or have I just mentioned all of them?
I haven't mentioned all of them, but those are the main ones. I mean, more generally, like map and reduce are by far the most common.
Okay.
But the point is that, the point is to start thinking of lists as, as kind of, you write functions that take lists and return lists, if you like.
Okay.
Yeah, so you should write functions that take lists rather than single values.
Okay.
Yeah.
And let's say I have like 2 nested for loops, Patrick.
Yeah.
What would that look like in the map way of thinking?
You do you map, mm-hmm. and then you use map with a function that maps.
Can you type it, Patrick?
Yeah, sure.
As I told you, I'm not very good at imagining.
Okay,
stuff.
So let's say we have a 2-dimensional array, like
okay.
I don't know, 1, 2, 3, 4, and we want to double every element.
Okay.
Of this list.
Okay.
So what we do is to do that, we write map function x, no, let's do function I, return map function j times 2. high. Yes. So that's a little bit complicated, but so the idea is that each for loop corresponds to a map.
Okay. Patrick, I'm gonna say that well, it may just be because I'm not used to it, but it seems pretty much a little bit more cryptic than just a nested for loop.
Let me kind of expand. Let me make it a little bit less cryptic.
Okay.
Okay. Function double I equals return 2 times I. Function double I return map double I. And then we just write map double all 1, 2, 3, 4.
Okay. Okay. I see. Okay. I think this time, except for most of it being text, I think we pretty much achieved the goal of the podcast quicker than usual.
Yeah. Alright, so I do want to go over this thinking of lists as their own object. Like, does it make sense what I'm talking about there?
Yes.
Alright, cool. And the great thing is that once you start thinking in, like, actually playing with the language R
Okay.
is a very good way of getting around to this mindset. Like, with R, you almost never use a for loop.
Okay.
Because, like, most of the functions you're given, like, they kind of have map already inbuilt. Like, you don't have to type map.
Okay.
You just, like, I don't know, you just write double X.
Okay.
And that would automatically double all the elements of the list.
Okay. So every command is automatically a parameter to map?
Yeah. Like, not quite every command, but more or less. Okay. So it really, it really gets you in the habit of not using for loops.
Okay.
Because they're just pointless.
Okay. And I think this is also one of my, one of the things that have been stopping me from using Haskell, because, I think first you have to get into this habit of not using for loops and using map instead.
Yeah.
Before Haskell starts making, like, sense at all.
Yeah.
Yeah. So what else? Okay, so I guess one thing that seems to be a little bit related would be how recursive functions seem to be used a lot in Haskell, Patrick. Or in Scala.
Right. So the reason they use recursive functions, it's basically a way of having state without having like global variables.
Okay. But, well, I'd like to talk a little bit about those what's the name of the, there's like a parameter, like a method of a list that returns, like, let's say the rightmost member of the list. What's the name of that one? I can't remember right now.
Tail.
Taylor. One of them is tail and the other is head.
Yeah.
I can't remember. Yeah. I mean, this may be a whole other podcast to talk about, but, yeah. Getting into I've seen that, there's a whole way to write programs which entails, like, sending head or tail to a recursive function, and then working with the stuff inside the recursive function, right?
Yeah.
Yeah. Yeah. Probably, if when we talk about it, I should have, like, something prepared. An example of that.
Okay.
But yeah. Okay. Let's save that for another podcast, Patrick.
Okay.
Is there anything else you want to say about map and these kinds of higher class?
Yeah, there was one thing. So, like, using them not only makes your code shorter, but in a lot of cases it can make it more efficient.
Okay.
If you've ever heard of Google's MapReduce, I mean, the reason is that a lot of the time, the exact order in which you process elements of a list doesn't matter.
Okay.
Like, it does for printing, but, you know, let's say I just want to double all the elements in the list.
Okay.
Then it doesn't really matter if I, you know, double the first one first, then the second one second, then the third one third, and so on.
Okay.
I could just, like, jump around the list.
Okay.
Or, more importantly, I could break the list into two and tell, like, one computer double all the elements in this list and another computer double all the elements in that list.
Uh-huh.
And then just put the results together.
I see.
Yeah.
So, yeah. Okay.
So that makes things very efficient.
Yeah, I see. Yeah, I can see how that's efficient. But only in things where the order doesn't matter, right?
Yeah.
Okay. And, I don't know, is there anything else I should be asking? 'Cause I think I think we covered everything really quickly.
Go us. Alright. I don't think so. I think, you know, we may as well wrap it up.
Okay.
I'll talk
Keep
to you
it
later.
concise.
Yeah.
Okay. Thank you, Patrick.
No worries. See ya.
Bye.